Hello and welcome back. We are going to finish out Unit 8 with some 8.4 wonderful material here. Hopefully the way of doing this has been alright for you, and if not, then this is your last one. So we're going to get started. We looked the last couple units, or last couple lessons, at ways to prove triangle similar. 8.2 we looked at angle, and then in 8.3 we looked at the other two, which is side, and side, angle, side. So the end of the 8.3 kind of captures that right here. We're going to stray away from proving triangles similar to get back to some proportionality, setting up proportions. And the format of this looks a little bit different than the format of yours, but the theorems are all still there. So 8.6 and 8.7 are tied together because one is the theorem and then one's the converse, which just means you can flip the order of the if-then statement. So theorem 8.6 is right here, and I'm not going to spend a whole lot of time on these because my recommendation for you would to put these in your theorem tables. I would draw it and then also show what side lengths are proportional because of that. So if you have it in your theorem table, then I don't want to spend a ton of time going through the mathy part of these words. But basically 8.6 says if you have a triangle, inside that triangle you got a set of parallel lines here, then it's going to divide that up proportionally. Okay, so that if you notice the ratio here, this side over this side will be proportional to this side over this side. And then the converse just flips that. If you know already that those things are proportional, then you can conclude, oh, these lines must be parallel. Okay. Very similar to that, now we don't have two parallel lines, we actually have three parallel lines in theorem 8.8 here. Once again though, if you have three parallel lines, it's going to cut this thing up proportionally so that this side over this side will be proportional to this side over this side. Okay, so the x and xz, that ratio will be the same as the ratio of uw to wy, which is written down here. Okay, so once again, just setting up proportions, make sure these get in your theorem table. There is one more, the triangle angle bisector theorem, which once again, if you have if a ray is bisecting an angle here, then you will also have some proportionality going on, so that AD over DB, this one over this one, will be proportional to AC over BC. That one right, those two right there. Okay, can't stress enough, make sure these get in your theorem table so that you can refer to it, so you have a diagram so that you can remember which one is proportional. So if you remember which sides are proportional, then it should just be setting up that proportion and doing cross multiplication, which we will do in example 1 here. QS is parallel to UT. We know that RS is 4, ST is 6, and QU is 9, and we're looking for the length of RQ right here. So if you had something like this in your theorem table, you should be pretty quickly, hopefully, be able to realize, hey, this is the one I'm using. So the side lengths are proportional. So that what that would look like in example 1 here is that if I took 4 over 6 RS over ST, that would have to be the same ratio as X or RQ over 9. 4 over 6 equals X over 9. Top one over bottom one equals top one over bottom one. Okay, now when you cross multiply this, 6x is equal to 4 times 9. Well, 4 times 9 is 36. Divide each side by 6, and you realize that RQ is a length of 6. Okay, so pretty straightforward example there, and hopefully you can kind of see the proportions that come from that. Okay. Example 2, I would first label. Here's a shoe rack where AB is 33 centimeters, CB is 27 centimeters, CD, this one is 44 centimeters, and DE is 25 centimeters. Explain why the shelf is not parallel to the floor. So in this case, we're going to use the converse, because if we can show that this one over this one is not the same as this one over this one, then we have shown, okay, well then these can't be proportional. So first let's look at this ratio here, 27 over 33, CB over BA. I can actually take a 3 out of each of these, and if I take a 3 out of each of these, then that would simplify into 9 over 11. So this, this ratio over here simplifies into 9 over 11. If this ratio over here is also 9 over 11, then it would be parallel by the converse. If it's anything but 9 over 11, we would say that it's not parallel. Okay, so the ratio over here is 44 over 25. Well, I think you should be able to see that 44 over 25 is not going to simplify into 9 over 11. It's actually bigger than 1. 9 over 11 is less than 1. So since 44 over 25 does not simplify into 9 over 11, we can conclude then that BD is not parallel to AE. And so the shelf would not be parallel to the floor, is how you can kind of also interpret that. And if the shelf wasn't parallel to the floor, your shoes, I don't know, maybe they won't stay as well. But maybe it's some crazy IKEA furniture that if I assembled it, then it would not be parallel, but it would hopefully still work. Okay? So these are getting at both those first theorems. This is just the original theorem right here. Set up the proportion and solve, because we know that they're parallel. Here, we're given the sides. Can you show that they're parallel? We've shown that they are not, because the ratios were not the same. Okay. Example 3 looks like we might have a bunch of parallel lines here, so we'll probably be using that 3 parallel lines theorem, but actually it does not. If you read these directions here, it does not tell us that they're all parallel. What it tells us is that 1, 2, and 3 are all congruent. It tells us that FG is 120, that DE is 150, and CD is 300. Find the distance HF between Main Street and South Main Street. Okay, well, we can only do this if we have parallel lines, and we can actually conclude that we have parallel lines because it tells us that 1, 2, and 3 are congruent. Because 1, 2, and 3 are congruent, and these are all corresponding angles, we can say, since we have corresponding angles congruent, we can conclude that we have parallel lines. Okay, that's an important step, because you can't actually use this theorem, the 3 parallel lines theorem, if you don't have parallel lines. Well, the reason we do have parallel lines here is because you got some corresponding angles that are congruent. So now that we know that we actually have parallel lines, we can use that theorem, okay, where this side over this side, I'll label GH as X. Okay, or actually I'll write GH to show you this time. 120 over GH will be proportional to 150 over 300. This side over this side will be equal to this side over this side. Okay. And now if you cross multiply and solve here, you do 120 times 300, and if you end up dividing that by 150, you get that the length of GH is equal to 240, and you can make sure of that with your own cross multiplication there. Okay, so this right here, I've just found out that this is 240. But you have to be very careful, because originally the question asked for the distance HF. We needed this distance to ultimately find out what HF was, so this is what we solved for, but our final answer isn't 240. Our final answer is HF, which is this 240 plus this 120, which is 360. So 360, and I believe this is in yards, 360 yards. between Main Street and South Main Street. Awesome. And we'll do one more in example 4, using the angle bisector theorem. In the diagram, you know that there's an angle bisector going on, so we know that we can use the theorem 8.9. Use the given side lengths to find the length of RS. So if you remember what we know from the angle bisector theorem, this one over this one is going to be the same as this one over this one. So let's set that up. We need this side over this side. Well, we don't really know the length of QR. We know that this piece is X. We know that the whole thing is 15. So what I want you to notice is that QR, a way that I can express QR is that whole 15 minus this X piece right here. If the whole thing is 15 and this is X, then QR would have to be 15 minus X. So when I write my proportion, that's what my numerator will be. 15 minus X over this side, which is X, will be equal to this side of 7 over this side of 13. Okay. So now the cross multiplying gets a little bit trickier because you do 7 times x. 7 times x is 7x. When you cross multiply here, just make sure that you distribute this 13 to both terms. 13 times 15 is 195, and then you'll have a minus 13x. So both of those terms got multiplied by 13. Now I can add 13x to each side and get 20x equal to 195. And then when you divide each side by 20, you get that x is equal to 9.75. So since we actually are now looking for the length of RS, this x value gives us the length of RS, which is 9.75. So in this case, we are finished. So we just kind of went through each one of those theorems. Hopefully you can understand the proportions that you're setting up. Make sure that you get those in your theorem table so that when you get a diagram like this, you can know specifically what is proportional to what. Well, our Unit 8 time has come to an end. It has been wonderful virtually getting to know you. You can leave me some wonderful YouTube comments about the quality of my work, get me famous, and if I end up making money off this, I'll remember you and maybe even buy you a donut. So, Godspeed, much love.